going to talk about adding polynomials. And we're going to use two different formats, a horizontal format and a vertical format, which just has to do with how we line up our polynomials. Now, adding polynomials is like simplifying expressions, which you've already done a lot of. And if you recall, when you simplified expressions, you simply combined like terms, and we're going to do the same thing here. So let's jump into an example. You are directed to add the polynomials, and I'm just going to abbreviate polynomial with poly or polys. 3x squared minus 4x plus 7 and negative 6x squared plus 5x minus 2. These are trinomials in one variable to review some vocabulary. The solution, and we'll do this first in a horizontal format, is simply to write out your two polynomials, and to delineate them, I'll start with putting them in parentheses. So we have the 3x squared minus 4x plus 7, and pop a plus sign in the middle, and then we're going to combine like terms. We don't have to be concerned with changing any signs because we just have an addition happening. So what I'm going to do is just group like terms together. We'll start with things that have x squared and put them next to each other. We've got a positive 3x squared and a negative 6x squared, so 3x squared minus 6x squared. And especially when you're first starting out on these, a good thing to do is check them off as you finish them, or cross them off, put them in boxes. Give yourself a visual aid to help you keep track. We'll put together the terms that just have a plain old x. So we've got a minus 4x plus 5x, and then we'll put the constant terms next to each other. The 7 plus 7 minus 2. And now we can just simplify. We add or subtract the coefficients and leave the variables alone. 3 minus 6 gets us a negative 3, x squared. Minus 4 plus 5 gets us plus x, and 7 minus 2 is 5. And that is our answer. Now, when you use a horizontal format, it's really easy to make mistakes just by missing a term, leaving one out, dropping a sign. A vertical format is useful to help keep track of that kind of thing. So we'll look at the vertical format. And what you're going to do there is simply line up like terms vertically, and then proceed to add. So let's do that. Let's take, I believe it's the same polynomial that we just, or polynomials that we did, and let's add 3x squared plus 4x minus, minus 4x. We can always write that as plus a negative, plus 7, and a negative 6x squared plus 5x minus 2. So what we'll do is we'll start by lining up the like terms vertically. We'll put our x squareds one atop the other. Got a 3x squared and a minus 6x squared. Then the x's, minus 4x plus 5x, and last of all the constants, plus 7 and minus 2. And we'll just add. 7 minus 2 is 5. Negative 4 plus 5 is simply plus x. and 3 minus 6 gets us a negative 3x squared. Now where you find more utility for this method is if we are working with polynomials that are missing, that skip powers. Maybe it goes from a power of 5 to a power of 3, or longer. And so let's look at one where we don't just go down in order through the powers, we skip around a little bit. For instance, add 4a to the 5th power plus 5a squared minus 3 and 6a to the 4th power plus 3a squared minus x. We'll have to leave a little bit of room between our terms, 4a to the 5th, and we'll leave room for an a to the 4th. We don't need to worry about an a cubed, so we can put down 5a squared, room for an x, minus 3. And that takes care of the first polynomial. For the second polynomial, I'll put my plus in there, we're going to have a 6a to the 4th plus a 3a squared and a minus x. And this shows you where you have your gaps. The minus 3 is just going to come down, and minus x. 5 plus 3 gets us 8a squared, remembering to bring down your addition and subtraction symbols. We have a plain old plus 6a to the 4th, and then the 4a to the 5th also comes down, and that gives us our final answer. To recap, when we add, aim was really good there. When we add, we are simply going to combine like terms. And this is exactly like what you've done already with simplifying expressions. And that's the end of this segment.